Okay, so trapezoids and kites today. Our old friends. You remember what they both are, right? Okay, so this is 5-5. And make sure. All right. So 5-5. Trapezoids and kites. The first thing I need to make abundantly clear about these two shapes is that they are not parallelograms. So all those cool fun facts about parallelograms do not apply. They have nothing to do with trapezoids and kites. Okay, so we're going to start off with our friend the trapezoid. What does make a trapezoid a trapezoid? It does have 4 sides, so it's a quadrilateral. Anybody know? What makes a trapezoid a trapezoid? What does it have to have? Yep.
One set of parallel.
That's it. It has only 1 pair of parallel sides, not 2, because if you had 2, it would be a parallelogram. So it's a type of quadrilateral with exactly 1 pair of parallel sides. So for example, could look something like this, who knows, but I'd have to know that 1 pair of sides is parallel. If you, oh, well, let's talk about the parts of the trapezoid before I move on. Those 2 sides that are parallel to each other, we call them bases. So they literally have 2 bases. So you have a base here and you have another base here. The other 2 sides that are not the ones that are parallel, we call those legs. So here's a leg, here's another leg. Now, if you happen to have a trapezoid where the legs are equal to each other, we have a crazy name for that. Go ahead.
I was gonna say regular trapezoid instead of basic.
You're close. It's not regular, but it is a word that you know. It's isosceles. You could have an isosceles trapezoid. Huh, how about that? So isosceles trapezoid. So that's just going to be a type of trapezoid that happens to have the 2 legs congruent. So trapezoid with congruent legs. So you still have that 1 pair of parallel sides, but now your legs are congruent. Just like in an isosceles triangle, you're going to have congruent base angles in the isosceles trapezoid. So check this out. I'll draw a bigger one so you can kind of look at it. 1 pair of parallel sides if the legs are equal. So in an isosceles trapezoid, not only are the legs congruent, but they will also have congruent base angles. But here's the difference. Now you have 2 sets of base angles because you have 2 bases, don't you? So you have one pair of base angles down here that will be congruent. But then, this is where it gets wild here. You have another pair up here that are going to be equal to each other. All four are not equal, but you have these two sets. So there is another pair of base angles. Okay, so let's put a big star and say that our two sets of base angles in an isosceles trapezoid will be equal. Both sets of base angles in isosceles trapezoids are congruent to each other. Yes, Carson.
So what if you're taking an angle from one base and take an angle from the other base, won't those be supplementary?
Yeah. So these are still same side interior angles, right? Because you have parallel lines. So that means in an isosceles trapezoid, I could get away with just giving you one value. So let's try that. If I told you, I don't know, this angle right here is 70, you should be able to find me all of the other ones using what we just talked about. So if this angle is 70, you know angle 1 right away has to be 70 because they are a pair of base angles, so they have to match. But now Carson is saying, hey, these are same side interiors. They have to be supplementary, don't they? Yes, they do, because these are parallel lines, same side interior. So that's 70. What's this one? 110. And the same thing applies over here. That one's also got to be 110. Now, in a regular trapezoid that doesn't have these base angles the same, that concept still holds true, sort of. So these two angles would have to be supplementary. These two angles over here, 3 and 4, let's say, they have to be supplementary. They would just be separate from each other. So maybe I have like 80 and 100, and maybe here I have 120 and 60. You know what I mean? I couldn't be able to, if I had one, I couldn't find all of them. Yep.
If it was like a always, sometimes, never, if it said like, could parallelograms be a trapezoid?
Good question. What do you guys think? Could parallelograms be trapezoids ever? That would be a never. Because they have very specific definitions. Parallelograms have to have both pairs of opposite sides parallel. And trapezoid is exactly one. Right? It's not like isosceles where it's like at least two sides. Nope, it has to be one or it has to be two. So there's no overlap between those two. It's either a trapezoid or a parallelogram, can't be both. Okay, so what else do we have to talk about with isosceles trapezoid? I think that might be it for the isosceles. Okay, cool. We do have, give me 1 second, because some books use one name and some use another, so I forget which. I see it in my book here, but I can't remember if we kept it with the same word or if we switched it. Which is annoying, but whatever. We left it with medium. Okay, cool. All right. So any questions so far on the isosceles trapezoid or regular trapezoid? No? So far so good? Okay. Let me mark this. I got to flip my page over. Remember the segments in a triangle, the median, altitude, perpendicular, bisector, all that? So we kind of have one segment in a trapezoid, the median. median in a trapezoid. It's a little bit different because now we're talking trapezoids instead of triangles. Median in a trapezoid. And this, it's confusing because it feels more like a mid-segment, because this is going to connect the midpoints of the legs. And this could be isosceles trapezoid or not, it doesn't matter, any old trapezoid. So I'll do a non-isosceles one. Okay, so I have my pair of parallel sides. So if I wanted to draw a median and a trapezoid, I need the midpoints of each of the legs. So remember, the legs are the sides that are not parallel. So there's about a midpoint. If I sort of eyeball it here, there's another one. So when I connect these, that is the segment we refer to as the median in a trapezoid.
You have an isosceles trapezoid. Wouldn't the median always be parallel to the two bases?
Actually, it's true all the time, even in this one. So we have two fun facts about the median. There's the first one. The median is always parallel to the bases. Parallel to the bases. And then the second fun fact, this one's weird. It has to do with the length. Now, hopefully you can see that the median is not the same length as either of the bases. But what it is,
Oh,
go ahead.
is it the difference, or not the difference, the average of the two?
You're close. It's half the average. Yeah, so you want to take, oh, no, I'm sorry. Back that up. You were right. Just take the average, right? Because you're just adding the two, taking half to find the average. Okay, so parallel to the bases and its length is the average of the two bases. So when we say average, remember that means you're adding them together, dividing by 2, right? So it's 1/2 their sum, in other words. Okay, so I'll just say add bases, divide by 2. Let's talk about fun facts that trapezoids have, if any. Would you think that trapezoids have perpendicular diagonals, let's say? No, they do not. Would they have diagonals that are equal to each other? Could it happen? Yes, it can happen. What type of a trapezoid do you think has congruent diagonals? Eve? Yes. So let's put a big star with some fun facts. All right, fun facts. Isosceles trapezoids have congruent diagonals. Which makes sense, right? If you draw it out, it makes sense that if these are the same, that the distance from here to here would be the same as the distance from here to here. that makes sense. Okay, so I've got that. Do the diagonals bisect each other? Heck no. Sorry, I didn't hear you said yes. No, because, and I'll tell you why. If you have a shape where its diagonals are bisecting each other, you have a parallelogram. That was one of the ways to prove that a parallelogram is a parallelogram, is to show that its diagonals bisect each other. So that does not happen, and I don't care if it's an isosceles or not isosceles. It will not have diagonals that bisect each other. Really, that's the only kind of fun fact. Oh, besides the isosceles trapezoid having the congruent base angles, but we already talked about that. Yeah. So I think, let me make sure that that's all that I wanted to tell you about, but I think that is. Oh my gosh, kites. We didn't get the kites. I'll get the kites tomorrow. Yeah, remind me. But I mean, or okay. So why don't we do this? I'll give you a homework, but it won't be due until I don't even know what day today is. What's today? Tuesday? So it won't be due till Thursday. So if you wanted to start it now, because I do have to, I mean, you can read the, actually, is there even stuff in here about kites? There might not even be kite stuff in your book, but let me give you a trapezoid homework. Let's see here. Why don't we do page 192. 192. Let's do 1 through 9 odds. We'll go on to page 193. And then why don't you just try how about 12? Whew. Sorry, I'm deciding which ones I like and which ones I don't. How about 11? Let's just keep going with odds through 19. So change that from instead of 1 to 9, let's make it 1 to 19. We'll just do the odds. That should be fun. Oh, wait. You totally want to try 21 to 23. Let's do 21 to 20. Winky, wink, 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 21 to 25. Wink. Look, I'll even draw a wink. Winky. Is that how you draw one? I don't know. Close enough. Gosh, I wonder why those would be important. Who knows? Who knows? I'd look at those ones too. Oh, those are good questions. I'm moving it to Thursday, but it will be through 5. Yeah. All right. Any questions right now? No? Okay. So again, not due until Thursday, but there's no kite stuff on there, so you could do it tonight and just get it over with. So tomorrow I will finish kites. I will do a little bit of review for the quiz that we will now have on Thursday. Okay? Okay.